This is the first part of the DevOps. We've already discussed things about Bill, so we won't add anything. Let's see the new things about testing. Well, at testing level, we can create unit tests. We'll be able to test procedures and data providers. Let's see what the idea is with a basic example. We've got this procedure which allows us to upload a complaint. Right button gives you a new option, which is unit test. The unit test creates the basic structure. What we've got here is a new object, like a unit test, programmed in the same way we program a procedure. It is preloaded with a structure that simplifies our work. In the Act section, the procedure is open with all parameters that are loaded with a case data. We'll see where it comes from. And response, which is the exit value of the procedure we are testing. In the Assert section, we have the validation of the result obtained on the basis of expected value defined in the test case data. Test case data contains the data for each test case, as well as a data provider facilitating uploading our test data. Let's start making a test for a happy end, when all data are valid and the insert is expected to be inserted correctly. For ID users, we are going to use the data in the initial upload, so we are sure they are valid. For the other fields, we're going to define data that makes sense. In the response field, we're going to put a value that gives a response in case of success. For error, we're going to put in something that will make us identify the error, let's say case 1. This question of the error message, when we make an assert, we're going to say we want to compare the expected value against the obtained value, and then we'll put in a message in case the assert fails. That message can be anything, and we can use it in the way we want it. In my case, what I try to do is to identify the number of the test case, but that message can be used as you like it. Now that we have loaded case data for the test, we can execute unit test. We can run it with the right button. When we do that, GeneXus will specify the necessary programs to run the test. When it's complete, we have the test results viewer, and we can see the results of the tests. In our case, the assert was successful. That is, the expected value is the same as the obtained value, and you can see it here. Let's see now a case where we put in invalid cases and we expect the test to fail. Rather than the test to fail, we expect that the result of the procedure is an error. Let's hope that the test performs well. To that end, we define a test where all parameters, exit parameters, the procedure uploading the complaint, are empty, in blank, and the message that we get is the message in case of error. The message it identifies that whenever there are no data, there will be an error. So what we'll do is the same that as what we've done, right button, and we run the test. To our surprise, the result of the test isn't successful, and some of the asserts were not executed. Is that all right? Good. To see the details of the assert involved in a test, we're going to click on it, and below we're going to see each one of the asserts and their results. Now, the assert that was not successful pertains to the first test. That is the message that we allocated to our happy case. Now, why was it successful the first time and it isn't successful now? Well, the single index, the description plus user plus date, is the way we are trying to make the test, since given the rules of our business, it's not possible to upload registers with the same information. Therefore, we're going to make a trick for our test to work and include something that varies in each test. For instance, time start. We can run the test once again, and as expected, our test is successful. we can see how easy it is to make a unit test and add test cases. Let's see now using test-driven development techniques. Now, we'll describe the complaint, but it will be empty. The rest of the fields are valid. Therefore, if the complaint has no content, then we expect it to fail. The error message, in the case of the state, if there is no message, then there will be a message of error. Well, our test isn't successful, and the case we've just added is the assert is failing. And it's not going to be that easy when you do it. Now, when we click on the plus button, we can see what the difference is. We were expecting to have an error message. However, we obtain a message that the register had been, that the data had been inserted correctly. We are making this TDD practices because in the complaint, we had never included this validated data. So we know the test is going to fail, and we validate that it fails. Then we're going to make the implementation, which is to add a rule in the complaint transaction saying that the description field can't be empty. We run the test once again, and we can see that the test is successful. Therefore, we could continue the TDD test, adding additional information, for instance, that the address is not empty, or etc. This diagram represents the cycle of TDD. First of all, we add a test catching the expected behavior. We see that it fails because it hasn't been implemented. We write the code for the expected functionality, and we run the test to see that it's successful. Once again, we can make a refactor to improve implementation. The TDD states that there is a minimum TDD, and so we can make the refactor knowing that the test will realize in case we break the functionality we had implemented. In fact, we can work in both ways. We can do the TDD, that is running the test first, or we can do it afterwards once the functionality has been implemented. This functionality is good for any of the two scenarios. I would also like to point out that these examples are very basic. Perhaps it hasn't got much sense to make a test to see if a mini component is making an insert. GeneXus does that, and with its versions. But it could be meaningful if you run the test, if the transaction rules are being executed in the way I expect, because in that way we are testing our business rules. If we do it in this way, we can assess how the rules are triggered, and we need not go up to every screen and test it, so we're saving part of what would be a manual thing. An interesting point here is that our test is validating the response message of what has been inserted, but we don't know whether the data is saved in the database. Let's see how we can add a validation that the data are in the database. We can add more asserts to our test. Here I'm going to add an assert of the values in the database for the value I've just inserted. In case the response gives you a message like thanks, etc., I'm going to look on the database, making an for each, because I know there is one single key, and I'm going to make an assert of the rest of the attribute, expecting the values. In case there is no record with this condition, I'm going to force the result, making a forced assert. Now, that forced assert is my own invention. I don't know if you were thinking about this too, but if you want to trigger an error of something that isn't expected, well, that's a possibility. Something that's important to mention when we run the test is that there are three types of assert: numeric, string, and bool asserts, so that we can more easily compare the different types of data. once the test has been run, we can see that the result is the same, it's successful, but we've got more asserts because we are validating that the data are recorded on the database. So far, we've seen how to run a test, but in our menu, we can see all the tests defined. And here we only have one, but we can run any test. And we can run all tests with just one click. And very quickly, we can go to the results viewer of all the tests. As an overview, then, we've seen how to create unit tests, and for data providers. We haven't seen that for data providers, but it's just the same right button. We've seen how easy it is to create this test, clicking on the right button, and the test structure is created. We've seen how easy it is to add test cases, modifying data provider, and adding additional cases. We've seen how how it's possible to use TDD practices, since these unit tests are in GeneXus IDE, and also that each unit test add to the test suite we can use to validate each build. We've done it manually, but it's possible to do it automatically as part of the continuous processing. I'm going to take advantage of the time we've got left, and let me share with you what I was thinking when I was preparing this test. In fact, when we make unit tests, many times we realize that in our initial implementation of objects, they could have been better. We could have got more information. For instance, if I would like to test the various rules of transactions, since the insert procedure is only giving me a message saying error, something's happened, try later, that's not good to validate whether it's really checking that my description wasn't in or the address wasn't in. So I realized that I should probably go back to something more interesting. So in practice, unit tests help us to develop things that at the end of the day, they will be useful because those procedures that are more encapsulated or more robust would be better. In the case of the return of error message, can't you capture the messages that GeneXus provides, for example, in the case of mini components? Well, the procedure, instead of returning a written message, could, but that's not a mini component. You are making the procedure where you're having access to a table, and that table has a transaction associated to it, and any errors that will come out on the test. I don't know if I'm making myself clear. I mean, when I have a mini component and I get an error, I get the error messages. Now, in the case of the test, it's not working with a business component, but I would like to have the errors imply the transactions. Yes, exactly. That procedure that the business component is using, instead of the response returning a string, could be returning a message or a code or something that whoever the procedure calls provides more information to know what to do and, in fact, to be able to test it better. Yeah, yes, I agree. It could return the message itself, yes. Rather than usability, my question is about the following. I think that many procedures are created to develop testing. When I develop this later and I want to publish my app, this is like a separate module. Is it packaged or is it at your own free will? Well, right now, that is most certainly something that in future versions, this is going to be improved. Now, when you click on the right button and you create a unit test, it's created in the same folder of the object that you're testing. Objects in GeneXus are different objects. This would make it possible so that when you make the deploy units or whatever for the deploy, you separate it. But in fact, right now, they are all there. And yeah, I would like to clarify something here about deployment. Unit tests that you create call your procedures and your real objects. So when you make deploy, you are marking some real object of yours. So the objects created for unit testing aren't in the calls trees because they are callers of your objects. So they're not in the caller trees, and when you deploy, they're not going to be shown in deploy, even if they are in those folders, but they're not called, and that's why they're not going to be there. Well, if you make a deploy, yes, I agree.